Good morning, everyone. Thank you for watching my last video, and it tends to continue from where we stopped. So in this phase now, in the last class, we were able to discuss differentiation. You understand? We have discussed differentiation from first principle. We have been able to as well discuss the sum and difference rule. I've been able to introduce the formula to you. We have discussed the sum and difference rule, and we have discussed the chain rule as well. You understand now? But today we are going to discuss the product rule. Yes, the product rule. So now, the product rule, let me first open your eye to the formula. So the formula says if y is a product of two functions, you understand? Let's say the two functions are u and v, for example. So if y is a product of these two functions in question here, then the dy over the x of this function will be my u dv dx plus v du dx. Yes, I'm going to back this up with an example. As you can see the formula here, if y is a product of two functions, you realize that these two functions are in the form of multiplication product. You understand? So the differential of the function is giving us this particular thing we have here. So let's cite an example. Differentiate y is equal to 3x squared the cos of 4x with respect to x. Solution. Now the question says we should differentiate 3x squared cos 4x with respect to x. Now that tells you, look at the question very well. You realize that they are in the form of multiplication. We can rewrite this one as 3x squared multiplied by cos 4x. Yes. So that means we are bound to introduce this. We are bound to introduce the product rule into solving this problem. You understand? So remember that we can actually split this thing into u and v. So we can be having u as my 3x squared and likewise v as my cos 4x. You understand? And remember that the dy dx of this function then becomes the dy dx of the function becomes u dv dx plus v du dx. So that means I need to get my du dx. I need to differentiate u with respect to x in this case here. So differentiating u with respect to x, remember the logic behind this. You have 3x squared, isn't it? Multiply, take the power to multiply the base. That's 2 times 3, that's a 6x. Then deduct 1 from the power, that's 2 minus 1, which end up giving you 6. Now let me obtain my dv dx. Now dv dx looks a little bit complex. You understand? It requires more of me. You understand? It requires a knowledge of function of a function in this case. You understand now? Now take a look at what I'm going to do. So first of all, we assume let u be equals to 4x, for example. I only know the differential of cos x, the differential of sin x. I don't know that of cos 4x. So we have to assume. You understand? By assuming, we assume u is 4x in this case now. So if u is 4x, shall we differentiate u with respect to x in this case? So my du dx is going to be 4. Come back here. V is going to be cos. In place of 4x, remember you have replaced 4x with u. That's cos u. So what might be, let's then differentiate v with respect to u. That's dv du, which will give you, remember the differential of cos is negative sign. So the differential of this v now will be minus sine u. You understand? So remember we are finding dv dx. So my dv over dx will now be my dv over du multiplied by du over dx. Yes, this is a concept from your function of a function chain rule. So which end up giving you, what's my dv du? dv du was gotten to be minus sine u multiplied by du dx is 4. So together I have minus 4 sine u, which is minus 4. The sine of u is 4x. Don't forget. So now that I've been able to get this one, what next do I need to do? Very simple. Now remember, the reason why I actually went in this direction was because I need to get my dv dx based on the formula I have here. I already have my u. dv dx, which was the result I got here, my v, which was this, and my du dx, which was the result I had here too. So shall we introduce this into the formula? By introducing that into the formula, let's see what I tends to have. So introducing that, dy over dx would then be u, which is 3x squared. That's 3x squared. You understand now? Then dv dx, which is a negative 4 sine 4x plus my v again. What's my v? My v is cos 4x multiply by du dx, which is 6x in question here. So my dy over dx would now be, so let me quickly clean so that we can at least get what we are doing together, so that we don't get things confused. Let me introduce the formula again. We are using y is u, y is dy dx is u dv dx plus v du dx. So dy over dx will now be u, which is I gave you y is s 3x squared, the cos of 4x. So when I said u is 3x squared, likewise v is cos 4x. So my u is then 3x squared into dv dx, which was minus 4 the sine of 4x, plus my v, which was cos 4x open bracket du ds, which was my 6x in question here. So I will end up having, then expand this, you have minus 12x squared the sine of 4x plus 6x the cos of 4x, which is the required solution to that very problem. So I want to believe there's no problem on that. You understand? So let me introduce another example to you. Let's assume y is equals to s squared 5 raised power 3x. Find, if y is that, find the dy over dx. That is, differentiate y with respect to x. Now shall we differentiate? Now first of all, remember, this one looks something, it looks similar to that your product. You understand? So since it is similar, we can write this one as s squared multiplied by 5 raised to the power of 3x. That means we can split this thing here into in terms of u and v. So by splitting, I will have u is x squared and v is 5 raised power 3x there. So my du over dx, remember the formula. The formula says dy over dx is u dv dx plus v du dx. So then my du over dx would then be what? Differentiating u with respect to x. Yes, remember the concept. You have 1s squared. 2 times 1 is 2x. Then deduct 1 from the power. That will give you 2x. Then what will be my dv dx? My dv dx is going to be, so my v originally was 5 raised power 3x. Now there is a rule here. I don't know if you are familiar with the rule, but I'm going to show you how the rule was gotten as well. So in conquest to this, how then do I differentiate this one? You need to introduce log to both sides. On introduction of log to both sides, because the reason why I'm doing all this is for me to get my dv dx. So introducing log to both sides, I will have log of v is equals to the log of 5 raised power 3x. Yes, I've just introduced the natural log to both sides. So introducing that, remember the law. There's a law that says the log of m raised power p, power law, is equals to p log n. Yes, I believe we still remember that. So introducing that one here, we have 3x the log of 5, isn't it? Now let us differentiate v with respect to x. So my dv dx in question here. So I will have, now if I differentiate this one, I'll differentiate, remember I'm differentiating with respect to x. So differentiating v here, I will get 1 over v. If you differentiate log of, remember the differential of log x is 1 over x. You understand now? So differential of log v will be 1 over v. So remember, I am differentiating with respect to x, not with respect to v. So you must indicate here this is implicit differentiation. You understand? You must indicate that you are differentiating v with respect to x. So here I'll be having, yes, you need to separate this one, u and v. You need to introduce another product rule here. So you call this one u, you call this one v. Abi u 3x dv dx. If you differentiate log 5 with respect to s is 0, plus v, that's log 5. You understand now? Differentiate 3x with respect to x is 3 multiplied by 3. You understand now? So that 1 over v dv, or rather I can write it as dv dx multiplied by 1 over v is 0, that's 3 log 5. So that my dv over dx would then be, you cross multiply so that the v can multiply all those ones. That's v multiplied by 3 log of 5, isn't it? So that dv dx is going to be, what's my v? Originally my v was 5 raised power what? 3x multiplied by 3 log 5. Are you with me now? So this was my required dv dx. You understand now? So having known what dv dx is and du dx is, what next do I need to do? All I need to do is find my differential, find my du dx. So getting my du dx, all I need to now do, remember, my dy dx, rather, sorry, getting my dy dx is u dv dx plus v du dx. What's my u? My u was x squared. Yes, check the content of the last this thing. My u was x squared. My dv dx was 5 raised power 3x multiplied by 3 log 5 plus my v was 5 raised power 3x into my du dx is 2x. You understand? So that one gives you 5 raised power 3x times 3x squared, the log of 5, plus 5 raised power 3x times 2x. You understand now? You can then factorize, bring out 5 raised power 3x, but it's more or less like we are still going back to where we are actually coming from. So I want to believe you now have an idea of what differentiating using product rule is all about. So don't forget to watch, like, share and subscribe, and God bless you as you do so. Thank you.